Given a straight line through a fixed point 2, 3 intersects the coordinate axis. So let us consider the coordinate axis, x-axis and y-axis, and our fixed straight line is passing through 2, 3 intersecting the coordinate axis. Since 2, 3 is the point in the first quadrant, so let us consider 2 and 3. A line passing through it cuts the coordinate axis at 2 points. Say this point is P and here it is Q. And if O is the origin and the rectangle OPRQ, so R is the point here, OPRQ is completed, then the locus of R, let us consider R is the point H comma K. So we can consider the point P is H comma 0 since it is a rectangle parallel to y-axis and here QR is parallel to x-axis. So we can say the point Q as 0 comma K and point is 2 comma 3. So the equation of the line PQ whose x-intercept is h units and y-intercept is k units is given by x upon h plus y upon k is equal to 1, intercept form of a line. And this line is passing through two comma 3. So which implies 2 upon h plus 3 upon k is equal to 1, or we can write 3h plus 2k is equal to hk by simplifying. And since we require the locus of the point r h comma k, so therefore required equation, that is locus of r, can be taken as 3, in place of which we can take x, plus 2 k we can take it as y. So 3x plus 2y is equal to x into y. So which is our option B. Option B is the answer. Given orthocenter of a triangle a minus 3 comma 5 and centroid is given 3 comma 3 and C is the circumcenter is C, and then we need to find the radius of the circle having line segment AC as the diameter. Means we need to find the coordinates of circumcenter C. We know that orthocenter, centroid and circumcenter. The centroid B divides orthocenter and circumcenter in the ratio 2:1. So A is the point minus 3 comma 5 and B is the point 3 comma 3, and C, let us consider C is the point alpha comma beta, so that we can find by using the internal division section formula. We have mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Here the ratio is m is to n, m is 2 and n is 1, and x1 y1 is minus 3 comma 5 and x2 y2 is alpha beta. So we can write here 3 comma 3, that is the point B is equal to m times, so that is 2 times of alpha plus 1 times of minus 3 divided by m plus n, that is 2 plus 1 comma m times of, that is again 2 times of beta plus 1 times of 5 divided by 2 plus 1. So which can be taken as 2 alpha minus 3 divided by 3 is equal to 3. Comparing the coordinates, x coordinate and y coordinate, and here we can write 2 times of beta plus 5 divided by 3 is equal to 3. So on simplifying, we will get, so 2 alpha minus 3 is equal to 9 and 2 beta plus 5 is equal to 9. So 2 alpha is equal to 9 plus 3 12, and 2 beta is equal to 9 minus 5 4. So alpha is equal to 12 upon 2 is 6 and beta is equal to 4 upon 2 is 2. So we got the coordinates of the circumcenter. Circumcenter C is alpha 6 comma 2. And since we need the AC as a diameter, the radius, so we need to find the distance between A and C, that is a diameter, which is equal to under root of A point is minus 3 comma 5 and C point is 6 comma 2. So you can write 6 minus of minus 3, that is 6 plus 3 whole square, plus 2 minus 5, that is minus 3 whole square, which is equal to under root of 9 plus 2 minus 5 is 3 square, 9 square plus 9, which is root of 81 plus 9, 90. This is the diameter. So the radius we can take it as half of the diameter, that is half root 90, which is equal to half into root 90. We can write it as root 9, that is 3 into root 10, and this can also be written as 3 times root 5 by 2, because root 10 we can write it as, so we can write 3 root 10 by 10, sorry 2 is equal to 3 into root 5 into root 2 divided by root 2 into root 2. So root 2 gets cancelled. So 3 times of root 5 upon root 2. So that is 3 root 5 by 2. Option B is the answer. Given a system of straight lines as A times of 2x plus y minus 3 plus b times of 3x plus 2y minus 5 is equal to 0. And clearly we can say that the family of straight lines, the system of straight lines passing through the point of intersection of these two lines. One line is 2x plus y minus 3 is equal to 0, and another line 3x plus 2y minus 5 is equal to 0. So there are different infinite family of straight lines passing through the point of intersection of this. So let us find the point of intersection by solving two line equations. 2x plus y minus 3 is equal to 0 and 3x plus 2y minus 5 is equal to 0. Let's use cross multiplication method from second coefficient, that is 1 minus 3, then again 2 and again plus 1. Similarly for the second equation, 2 minus 5 and then again 3 and then again 2. So the first two columns are for x and the second two columns for the y and the last two columns are for 1. So let's write x upon the determinant 1 into minus 5 minus 2 into minus 3, that is plus 6. So minus 5 we can write plus 6. Similarly y upon minus 3 into 3 minus 9 minus of minus 5 into 2, that is 10, which is equal to 1 upon 2 into 2 4 minus 3, that is 1. So we can write x upon 1 is equal to y upon 1 is equal to 1 upon 1. So which implies x comma y is 1 comma 1. So our system of straight lines passes through 1 comma 1. So here is the point 1 comma 1 we can note. And now we need to find the line equation which is situated farthest from the point 4 comma minus 3. So whatever the line is also passing through the point 1 comma 1. Let us say this is our required line. This is a required line passing through 1 comma 1, but it is given it's the farthest from the point 4 comma minus 3. So let us take 4 comma minus 3 somewhere here. So it is the farthest, means that the perpendicular distance, the perpendicular of this line means our line must be perpendicular to the line joining 1 comma 1 and 4 comma minus 3. So slope of required line can be taken as that is minus 1 by m1, where m1 is equal to y2 minus y1. By using the 2 points 4 comma minus 3 and 1 comma 1, slope is y2 minus y1, that is 1 minus of minus 3 divided by 1 minus 4, which is 1 plus 3, 4 upon minus 3. Then the slope of required line can be taken 3 by 4. Hence equation of required line can be taken as passing through the point 1 comma 1 and having the slope 3 upon 4. So y minus y1 is equal to m times of x minus x1. That is 4y minus 4 is equal to 3x minus 3, or we can write 3x minus 4y, and minus 3 plus 4 is plus 1 is equal to 0. So this is the required line which is passing through the point 4 1 comma 1, and it is at a farthest distance from 4 comma minus 3. The meaning of farthest from the point means the perpendicular will be passing through this line. So we can go with an option D. Given two equal sides of an isosceles triangle, 7x minus y plus 3 is equal to 0, and x plus y minus 3 is equal to 0. And we have the property that the third side of an isosceles triangle must be the angular bisector of one of the angular bisector parallel to the angular bisector of the two equal sides. So if we can extend these two sides here, so we can find one angular bisector which is parallel to the third side. Since if it is parallel, then we can say the angles are equal. So here it is alpha, and here also alpha. So here also alpha, and here also alpha. So we can say this line is a angular bisector of the two equal sides. So let us find the angular bisectors or bisector of the angles of two equal sides of an isosceles triangle can be given by 7x minus y plus 3 upon root of 7 square plus minus 1 whole square is equal to x plus y minus 3 upon root of 1 square plus 1 square. So we can add 7x minus y plus 3 upon under root of 49 plus 1 root 50 is equal to plus or minus we can take here x plus y minus 3 upon root 2. So root 50 we can write here, 25, 5 root 2 we can write. So we can say 7x minus y plus 3 upon 5 root 2 is equal to plus or minus x plus y minus 3 upon root 2. So we can cancel root 2 and doing cross multiplication, 7x minus y plus 3 is equal to plus or minus 5 times of x plus y minus 3. That is 7x minus y plus 3 is equal to, if I take plus here, 5 times of x plus y minus 3, or we can write 7x minus y plus 3 is equal to negative 5 times of x plus y minus 3. That is, so here it is 7x and 5x, that is 2x, minus 5y minus 5y, that is minus 6y, and plus 3 and again plus 15, so plus 18 is equal to 0, or we can add here 7x plus 5x, that is 12x, minus 5 plus 5, that is plus 4y, and minus plus 3 here and again here minus 15. 3 minus 15 minus 12 is equal to 0. So you're getting two line equations. So by taking 2 common, we can get x minus 3y plus 9 is equal to 0, or we can say by taking 4 common, 3x plus y minus 3 is equal to 0. And since we required a parallel line, so equation of the third side, can be, since they are parallel, so we can get x minus 3y some constant k is equal to 0, or k1 is equal to 0, or we can write here 3x plus y plus some constant k2 is equal to 0. Since our line is passing through 1 comma minus 10, so which implies 1 minus 3 times of minus 10 plus k1 is equal to 0, or here we can write 3 times of 1 plus minus 10 plus k2 is equal to 0. So that is 1 plus 30, 31, plus k1 is equal to 0. And here we can write 3 minus 10, that is minus 7, plus k2 is equal to 0. So we can write k1 is equal to minus 31. So which implies the equation can be taken as x minus 3y minus 31 is equal to 0. And by taking k2 is equal to 7, and you get the equation 3x plus y plus 7 is equal to 0. So we can say clearly here x minus 3y is equal to 31 is one of the option, which is B. So option B is the answer. So the equation of side BC can be taken x minus 3y is equal to 31. We need to find the angle between the lines whose intercept on the axis are given a comma minus b and b comma minus a. Let us see the diagram. Let us consider a and minus b are, x intercept is a and y intercept is negative b. So let us consider this is a line. So we can write the equation of this line as x upon a plus y upon minus b is equal to 1. So we can write x upon a minus y upon b is equal to 1 is one line equation. And another line b and minus a. So we can take b and here it is negative a. If this is a and this is negative a and this is negative b and this will be b. So b and negative a, x is equal to b, sorry. So we must consider here this is b. Here we may consider b and negative a, let us assume here, so that the line can be taken. And this line we can write it as x upon b plus y upon negative a is equal to 1. So we got another equation, x upon b minus y upon a is equal to 1. Since we required the angle between the two lines, let us take the slopes. Here the first slope is nothing but minus a by b, that is minus 1 upon a divided by minus 1 by b, so which is b upon a. And the second slope we can write 1 upon minus a by b, that is minus 1 by b upon negative 1 upon a, which is a upon b. So the two slopes are given b upon a and a upon b, and we know that if theta is the angle between the two lines, then tan theta is equal to m2 minus m1 upon 1 plus m1 m2. So we can write m2 minus m1 is a upon b minus b upon a divided by 1 plus b upon a into a upon b. We can write a square minus b square upon ab divided by 1 plus 1. So we can write tan theta is equal to a square minus b square upon, this is 2ab. Or we can also write theta is equal to tan inverse of a square minus b square upon 2ab. So we can go with an option, or a square minus b square, or we can also take here negative also. So we may consider the option C. Since mod is there, so we may consider tan inverse of, or tan inverse of b square minus a square upon 2ab if I am taking m2 minus m1 minus m2 formula. So we can go with an option C. Given that a ray of light from the point P 1, 2 is reflected on x-axis at point A, let us take a, 0. The reflected ray is passing through point 5, 3. Here is the point 5, 3. And we know that angle of incidence is equal to angle of reflection. So we may consider the angle here. Let us take the slope of this line. Say this is Q. Slope of AQ is equal to 3 minus 0 upon 5 minus A, that is 3 upon 5 minus A. Let us consider to be tan theta if theta is inclination. And then slope of PA, we can write 2 minus 0 upon 1 minus A, that is 2 upon 1 minus A. And here we can consider this is angle theta, so this will be total pi minus theta. So the inclination of this line can be taken as tan pi minus theta, and tan pi minus theta is minus tan theta because in the second quadrant, and we can say that tan theta plus tan minus tan theta is 0. So we can write tan theta plus tan of pi minus theta is equal to 0. So tan theta value is 3 upon 5 minus A, and tan pi minus theta, that is 2 upon 1 minus A, is equal to 0. And simplifying 3 times of 1 minus A plus 2 times of 5 minus A is equal to 0. So we can write 3 minus 3A plus 10 minus 2A is equal to 0. Or we can write 13 minus 5A is equal to 0. Or A is equal to, we can consider 5A is equal to 13, A is equal to 13 upon 5. So when A is equal to 13 upon 5, so we can say the point A is 13 by 5 comma 0. So which is option A. So we can go with an option A, 13 upon 5 comma 0. We need to find the equation of the line which is concurrent with the lines 4x plus 3y is minus 7 is equal to 0, and 8x plus 5y minus 1 is equal to 0. The concurrent means passing through this point, line is passing through, and whose gradient is minus 3 by 2. So we need to find a line which is passing through the point of intersection of these two lines and whose slope is minus 3 upon 2. Let's solve the two equations. 4x plus 3y minus 7 is equal to 0, and 8x plus 5y minus 1 is equal to 0, and we can write 3 minus 7 and 4 and 3, and 5 minus 1 8 and 5. By doing cross multiplication, x upon minus 3 plus 7 5 is 35 is equal to y upon minus 56 plus 4 is equal to 1 upon 20 minus 24. So we can get x upon 32 is equal to y upon minus 52 is equal to 1 upon negative 4, or x is equal to 32 upon negative 4 is minus 8, and y is equal to negative 52 upon negative 4 is 13. So we got the point of intersection minus 8 comma 13, and having the slope is minus 3 by 2. So the required equation of the line equation can be taken as y minus y1 is equal to minus 3 by 2 into x minus of minus 8. So we can get 2y minus 26 is equal to minus 3x minus 24. That is 3x plus 2y minus 26 plus 24 is equal to 0, or we can say 3x plus 2y minus 2 is equal to 0, which is our option A. Option A is the answer. Given a point 2 comma 4 is translated through a distance 3 root 2 units measured parallel to the line y minus x is equal to 1 in the direction of decreasing ordinates. So to reach at point Q, if R is the image of Q with respect to the line y minus x is equal to 1, then we need to find the coordinates of R. So first of all, 2 comma 4 point is translated through a distance of 3 root 2 is translated to a distance of 3 root 2 measured parallel to the line y minus x is equal to 1 in the direction of decreasing ordinates. In the direction of decreasing ordinate means we can consider the point is here. Let me consider the point is here 2 comma 4. It is translated. Say this point is P to reach at point Q. Now since it is parallel to y minus x is equal to 1, so the slope is 1. So here also we can consider the slope is 1, and we know the coordinates. We can write x1 plus or x1 minus r cos theta and y1 minus r sin theta. Since the slope m is equal to 1, that is tan theta is equal to 1, so we can write sin theta is equal to 1 by root 2 and cos theta is equal to 1 by root 2, and r is equal to 3 root 2 units. So we get the coordinates q as x1 minus, that is x1 y1 is 2 comma 4. So 2 minus r, that is 3 root 2 into cos theta, that is 1 by root 2, comma y minus, that is 4 minus r into, that is 3 root 2 into 1 by root 2. So we can say q point as 2 minus 3, that is negative 1, and here it is root 2 gets cancelled here, 4 minus 3 is 1. So the point q can be taken as minus 1 comma 1. Now we need to find the image of the point q with respect to the line. So we need to find the image of this point. Say this is r, image of q. So image of the point concept, if q is a point minus 1 comma 1, and with respect to the line y minus x or minus x plus y minus 1 is equal to 0, or this can also be written x minus y plus 1 is equal to 0. To get the image of this point, So let us consider r is h comma k. So we got the concept that h minus x1, that is h minus of minus 1 upon coefficient of x is a 1 is equal to k minus 1 upon negative 1 is equal to minus 2 times of ax1, that is a is 1 here because we are using the formula if x1 comma y1 is the point and if h comma k is the image of this point, then we have then the line equation is given with respect to the line ax plus by plus c is equal to 0. So we have h minus x1 upon a is equal to k minus y1 upon b is equal to negative 2 times of ax1 plus by1 plus c upon a square plus b square. So minus 2 times of ax1 can be taken as here a is 1 into minus 1 and again minus 1 into minus 1 and again plus 1 divided by a square plus b square. So we can write 1 square plus minus 1 whole square, that is h plus 1 upon 1 is equal to k minus 1 upon negative 1 is equal to, and here we can write 2 upon 2 1. So h plus 1 is equal to 1 and k minus 1 is equal to negative 1. So h is equal to 0 and k is equal to 0. So we are getting the image of the point is 0 comma 0. So we can go with an option A. Given P1 and P2 are the length of the perpendiculars from the origin upon the straight lines, x secant theta plus y cosecant theta is equal to A and x cos theta minus y sin theta is equal to A cos 2 theta. Then we need to find the value of 4 times P1 square plus P2 square. We know that the perpendicular distance from any point, say x1 comma y1 upon the line ax plus by plus c is equal to 0. So we can write the perpendicular distance Pm is equal to ax1 plus by1 plus c mod upon root of a square plus b square. So let us use this formula here. So perpendicular distance from origin upon the line x secant theta plus y cosecant theta is equal to a, or minus a is equal to 0. So we can say from O to M, let us consider O to P, O to M, let us take OM is 0 into secant theta plus cosecant theta into 0, 0 into cosecant theta minus a mod upon root of a square plus b square, that is secant square theta plus cosecant square theta. So which is given by P1. So P1 we can write it as mod of negative a divided by secant square is 1 by cos square plus cosecant square is 1 upon sin square theta. That is P1 is equal to mod of negative a upon under root of sin square plus cos square 1 upon cos square theta into sin square theta. So this can be taken as mod of negative a into cos theta into sin theta. Similarly, for the second line, distance from origin 0 comma 0 to the upon the line x cos theta minus y sin theta minus a cos 2 theta is equal to 0. So let us consider ON, which is given by P2 is equal to perpendicular distance, that is x into 0, that is 0 minus y into 0 sin theta into 0 0 minus a cos 2 theta divided by under root of cos square theta plus of minus square theta sin theta whole square. So we know cos square plus sin square is 1. So we can write P2 is equal to mod of minus a cos 2 theta divided by 1, which is mod of negative a into cos 2 theta. And here also we can write P1 is equal to mod of negative a into multiply and divide with 2. 2 cos theta sin theta is sin 2 theta. So 2 times are we can write 4 times of p1 square, or p1 square is equal to mod of negative a whole square divided by 4 times of sine square 2 theta. So which implies that 4 times of p1 square is equal to mod of negative a whole square into sine square 2 theta. And similarly here, p2 square is equal to mod of a whole square into cos square 2 theta. Adding both, you will get 4 times of p1 square plus p2 square is equal to negative a mod whole square into sine square theta plus cos square theta is 1. So since it is a square, mod a whole square, so we can consider a square. So 4 times p1 square plus p2 square is equal to a square, which is our option A.